All right, so we're getting started with Unit 7 today. We kind of have two separate concepts that kind of go hand in hand a little bit, and they're thrown into this one unit. So we're going to spend like the first half of the unit talking about radicals, which are square roots, cubed roots, fourth roots, any root really, and then rational expressions, which are fractions that have like variables, polynomials in the top and bottom and stuff. So let's turn to 7.1. And we've already done some things with squares. We've already looked at cubes. But you're also going to need to be able to recognize perfect fourths as well. And so we're going to take a minute and fill in several of these. And I'm going to show you an easy way to get this list on your calculator. So if you go to y equals, and you type in x squared, you type in x cubed, and you type in x to the fourth. So I just type those all in separate equations. And then look at your table. You've got your list right there of perfect squares as far up as you need. Okay. So starting at 1, I want you to fill in perfect squares, cubes, and fourths, as many as you can there. There you are. And I only went up to 4,096 on the fourths. All right, so we're going to look at the specific parts of a radical. I'm going to give them like names, terms that I may use, so you need to be familiar with those. The first thing is the index. So whatever root it is, if it's the fourth root, the index is 4. If it's the square root, the index is 2. Now this symbol is just your radical sign. And then the number under your radical sign is called the radicand. R-A-D-I-C-A-N-D. Now, sometimes we won't see an actual number in this index spot. If we don't see a number there, what do we assume that it is? 2. It's a square root. So we assume that n equals 2. So here, we have some perfect squares, cubes, and fourths. What is the square root of 16? 4. But what do we really need to include with those square roots? Y'all remember? Plus or minus. So technically, if I do positive 4 squared, I get 16. If I do negative 4 squared, I still get positive 16. If you do it right and put the parentheses around it. So what is the square root of 121? Plus or minus 11. Yeah. What about the square root of 289? 17. Yeah. Plus or minus 17. And then do you remember what we did with fractions? Yeah, you just take the square root of the numerator and the denominator. So this would be plus or minus 2/5, because the square root of 4 is 2 and the square root of 25 is 5. Now, when we get to perfect cubes, it is not plus or minus. It actually depends on the sign of what's under the radical symbol. So the cube root of 8 is 2. Just positive 2. Cube root of 343, 7. So that means the cube root of negative 125 is what? Negative 5. You don't have i's here because the cube roots can be negative. Because if I take, this is really negative 5 times negative 5 times negative 5, which is negative 125. So we're saying, what can I multiply by itself 3 times to get a negative number? And you can do that with the negatives. So what would the cube root of negative 1 over 27 be? Negative 1/3. When we get back to fourths, then it's plus or minus again. So the fourth root of 1 is plus or minus 1. What about 2,401? Plus or minus 7? Because technically I can do negative 7 times negative 7 times negative 7 times negative 7 and still get positive 2,401. So this one would be plus or minus 8. And then what about this last one? Plus or minus 3/2, 3 over 2. Good. So what this means is if I have a radical that has an even index, so it's the square root, the fourth root, the sixth root, then if we have the even index and our radical is positive, that's the only way it can be. If it's an even index and a positive radical, our roots are real. We don't have any imaginary. And we have 2 of them. They're both plus or minus.
No, we didn't have to take it because it was like off. So we have to take it another day.
So we have 2 roots. They're plus or minus. Okay. Now, if we have an odd index, so let me see if I can, there you go. If we have an odd index, if the number under the radical sign is positive, we have real roots, but there's only one of them, and it's positive. I mean, this is basically what we just saw. If we have an odd index, so a third root, fifth root, seventh root, and there's a negative sign under there, it's still real, but your answer, you just get one of them that's negative. So you need to make sure when you are giving your answers that you follow this. So if you have an even index, make sure you put your plus or minus with your answers. So we're going to do some simplifying radicals, which we have done quite a bit. So we're going to follow the same steps that we did in the quadratics unit. So for example, when I have a square root, I'm just going to go ahead and make 2 square roots to break that up into. And that's really going to come in handy, especially when we have variables under there. So just get in the habit of marking your 2 perfect square roots. And we want to know the largest perfect square that goes into 117. So just like you did before, take 117 and divide it by your perfect squares. Now, you don't need to divide it by 144. You don't need to divide it by 100 because you know that 100 is not going to go evenly. So divide it by your perfect squares. So maybe if we start with 64. Now, you probably would have recognized that probably wouldn't go evenly anyway. 117, and then make your way down. 49. Nope. 117 divided by 36. Nope. You probably should recognize that 25 is not going to go. 16. Nope. It's 9. 9 is the largest perfect square. So 9 and 13. Try to always put your perfect square first. Now, since this one is the perfect square, that's the one that's going to get broken down. What is the square root of 9? 3. And then just bring down your square root of 13. And we're going to put a plus or minus in front because it is a square root. So they get plus or minus. Number 2, this one is 4 times the square root of 320. So I'm going to have 4 times my 2 square roots. Just like that. So what is that perfect square? It is 64. Yep. 64 times what? 5. Now, which of these is the perfect square? This one. So I really have 4 times 8 times square root of 5. What is 4 times 8? So this would be 32 square root of 5, plus or minus. This is not the fourth root. This is 4 times the square root. So we still have square roots. Yeah. And that is one thing. You need to be really careful with how you write these because once we start having other roots, make sure, like if this was the third root, make sure you would write that 3 really small so it's obvious that it's a third root, not 3 times the square root because there's a difference. So you have to be really careful. You need to be neat with your handwriting or you're going to cause confusion among yourself. All right, now we have some cube roots. So this one, number 3, is 2 times the cubed root of 48. So we have 2 times, and then I'm going to make 2 separate cube roots. And we basically followed the same process, but instead of dividing 48 by perfect squares, you have to divide 48 by perfect cubes. So you may even want to jot down a list of perfect squares, a list of perfect cubes, and a list of perfect fourths here on your notes so that you can just glance back and forth instead of having to turn your papers. So remember, it's really easy to get this list. If you want your perfect squares, type in x squared. If you want your perfect cubes, type in x cubed. If you want your perfect fourths, type in x to the fourth and get those, and you can look at your table. But if you are needing to go back and forth to divide, that may be too much work. So having them written out right next to you is beneficial. So 48, this is cube roots. So I'm dividing by these numbers here in the middle. These are perfect cubes. So, I mean, it would have to be either 27 or 8. Does 27 go into 48? No. So only 8 does. So 48 is 8 times what? 6. And so this is the perfect cube. So I'm going to circle that to make it obvious. We have 2 times, what is the cubed root of 8? 2 times the cubed root of 6. So our answer is 4 cube root of 6. Number 4, we have 3, and then I'm going to split up my 2 cube roots. And we're dividing by our perfect cube. So 108 divided by these numbers. And we'll stop with number 4 today. Since we're late on time, has anybody found it? It is 27. 27 times 4. So this is really 3 times 3 times the cubed root of 4, which is 9 cubed root of 4. And because these have an index of 3, it's not plus or minus. We just do positive.